Generative AI is sucking the oxygen out of the room. I believe most organizations should invest at least as much in predictive as generative if what you care about is value and returns. Yeah, we're in a bubble. And the claim is that we're rapidly approaching artificial general intelligence. That's a very problematic claim. I would go so far as saying it's a ghost story. The machine comes alive. So there's going to be this invisible force like the tractor beam bringing you into the Death Star. That's the antidote to hype, is to focus on concrete, feasible use cases. We're going to talk about predictive AI, generative AI, the difference, how the two really need one another, solve one another's great limitations in a hybridized fashion. Value is always about scaling a business. It's making things more efficient. That's the crux of the matter with predictive AI. Predict who's going to click, buy, lie, or die, commit an act of fraud, turn out to be a bad debtor.
Guardrails AI provides software and professional services to maximize the operationalized value of predictive AI and to create compelling business cases that gets your machine learning projects deployed and delivering value.
You guys sort of are very value oriented. You're really helping make the stuff accessible and delve into it concretely, but you're doing it in an energized, excited way. There's a lot of pressure to believe the AI hype. It's a very seductive story. There's a lot of extremely wealthy and powerful people publicly buying into it and promulgating the hype narrative. But we must continually counter that.
All right, everybody, welcome to the AI Space Podcast. I have Eric Siegel from Generative AI. Eric, what are we going to cover in this episode?
We're going to talk about predictive AI, generative AI, the difference, how the two really need one another, solve one another's great limitations in a hybridized fashion, how we can start realizing at least a good portion of what's generally an audacious promise of autonomy of generative AI with a new kind of reliability layer that's semi-autonomous and that involves developing the right guardrails in a bespoke manner for each problem that you're trying to solve. And we will try to put the hype in its place and differentiate between the real feasible potential value and use cases versus a lot of the public narrative that tends to overpromise.
That's awesome. All right, everybody, welcome to the AI Space Podcast. AI isn't just the future, it's a force rewriting the rules of business, wealth creation, and society. If you're a founder, innovator, or technologist, this is the AI show for you. The question you have to ask yourself is, will I blaze a path, follow the crowd, or be left in the dust? This is the 24th episode, and we're thrilled to have Eric Siegel, CEO of Generative AI. Generative AI provides software and professional services to maximize the operationalized value of predictive AI and to create compelling business cases that gets your machine learning projects deployed and delivering value. Eric Siegel is a best-selling author, former Columbia University professor, longtime leading consultant, Forbes contributor, and founder of the long-running Machine Learning Week conference series. He's definitely not a newbie in the space. He's been active in AI for 30 plus years as a co-founder and CEO of Generative AI. I'm Sanjay Kalluvilayil, founder and CEO of Stonehaas Advisors, your trusted advisor for AI founders and businesses focused on go-to-market strategy and execution. Eric, first of all, welcome. On the AI Space Podcast, we just jump right in to highlight game-changing insights that help founders drive innovation and scale business initiatives. What do you see as the hottest trends in AI?
Well, Sanjay, thanks so much for having me on the show. I'm very excited to be here. That's a great question. But, rather than hottest, I'd like to push the industry in a little bit different direction. That, we're talking here about agentic this, agentic that, and I think that tends to oversell. It implies a level of autonomy, and there's no concrete new type of technology that makes your generative AI project more agentic than not. Instead, here are the three that I would list. First of all, predictive AI should not be dashed on the wayside. That's everything AI, the majority of what people refer to as AI, enterprise machine learning, up until the advent of generative AI 3 years ago. This is the technology turned to improve your existing large-scale operations, targeting marketing, fraud detection, credit scoring, et cetera, et cetera. There's a long tail of use cases. Generative AI is sucking the oxygen out of the room. They solve different problems. They have principle they shouldn't compete, but they very much do for resources and attention. And right now, a lot of predictive is being put aside, but I believe most organizations should invest at least as much in predictive as generative. So there's a lot of untapped opportunity there. Great opportunities if what you care about is value and returns. Generative AI also has lots of great opportunities. Large language models are the most amazing thing. You'll hear me today probably push back against certain kinds of hype, but I'm certainly not criticizing the technology, only some of the stories told about it. I think large language models are amazing and they have a lot of potential use cases. But after a certain scope, you pretty much need to kind of harness it, or that is to say, to tame large language models. And the way that that's going to happen is some kind of new discipline and toolkit, which I'm calling the reliability layer, so that it's actually reliability. So all the issues, even if they only happen a small minority of the time, and that goes a lot more than hallucinating, getting things wrong. It also could be saying something inappropriate, offensive, getting off topic, disclosing sensitive information, enacting a transaction that it shouldn't, purchasing the wrong product. There's so many things it could do wrong. And even if it does things right the majority of the time, which is amazing and unprecedented and something we couldn't imagine just a few years ago, if it's not getting it right, the whole system's not viable, won't deploy. And that's what we're seeing, right? Everyone's now familiar with the MIT study from August showing only 5% of AI pilots are reaching production. There's a similar thing that's been going on for decades now with predictive AI, in fact. So there's all this untapped potential. How are we going to bridge that gap and get these? It's very easy to work up an impressive demo. How do you get it robust enough to productize? So by reliability layer, I'm talking about a few things. It's guardrails. It's a semi-automatic development of the guardrails. Humans stay in the loop. Humans are part of the loop when the guardrails fire, when something might be going wrong. And each such project is very much form-fitted. We don't have a panacea. There's still a lot of customization to solve any one particular business problem, any one project meant to be deployed. It has to be very much form-fit, bespoke, and customized to get the architecture. And a big part of that will end up actually being hybridizing between generative and predictive. So that's my gist. I'll just list the three because you asked for three. There's a lot of untapped potential with predictive, despite all of the attention being put on generative. There's also a lot of untapped potential with generative because most of those are not getting deployed. And the need to develop a new kind of discipline and toolkit and paradigm, which I'm referring to as a reliability layer, so that we have this human-in-the-loop process bespoke for each project and actually get the things deployed.
Oh, that's great. And I think we're going to dive deeper into those as we get further into the conversation. So second question is, what do you see as the top AI strategies to grow and scale a business?
Well, everything that I just said was about how do you develop value. And value is always about scaling a business, right? It's making things more efficient, right? So just that's the crux of the matter with predictive AI. Predict who's going to click, buy, lie, or die, commit an act of fraud, and turn out to be a bad debtor. Any outcome or behavior for which there be value in order to improve existing large-scale operations. The holy grail for improving large-scale operations, which consist of millions of micro decisions, is prediction, is forecasting, putting the odds on the outcome for each individual, which directly informs the action or treatment taken to that individual. That's why, as I said a moment ago, predictive AI is the type of AI, the type of technology you turn to improve your existing large-scale operations and improving efficiencies, whether it's cutting costs or improving revenue. One way or the other, it's the bottom line improvement. That's what makes things scale. It's about pursuing those KPIs, profit, savings, whatever the business metric that matters for the improvement and assessment of that operation. So in a nutshell, that's completely on the nose. That's how you scale business using number crunching. By definition, is predictive AI, otherwise known as predictive analytics or enterprise machine learning, where you're predicting the outcome or behavior to improve that operation. That is not now. Generative AI has a somewhat overlapping, but mostly very distinct set of use cases. And to be clear, the difference between predictive and generative isn't so much about the core technology. Both of them harness machine learning, which is learning from data to predict, but applied on different levels in different ways. And really, these are two different categories of use cases of machine learning. And generative, there's most people are familiar. This is what gets all of the attention. Generative is much easier to use than predictive, or potentially not, but harder to use well in terms of concrete, feasible, value-driven deployment. But it's easy to understand, much easier than predictive. Predictive is not that hard to understand at all, but sometimes relegated as arcane. Whereas generative, because you interact with, by definition, you interact with it in English or other human languages. That's why it's called a language model. All you want to do is type what you want it to do. And in fact, when you're creating a more bespoke solution meant to solve a particular business problem, the prompting is also just written in English, right? So the potential use cases are sort of clear. Everyone knows generating content, generating code, education, replacing kind of customer service agents or other chatbot types things, or performing data analysis, right? All of these kinds of very different than the kinds of use cases I listed a moment ago with regard to predictive, and yet still also very much aligned with scaling. But there's so many different opportunities and potential ways that either type of AI could be deployed for your organization. So the exploration of where's the lowest hanging fruit, what's the best value proposition, is the exploration of where do we think is the best opportunities to grow and scale our organization.
Cool. Well, Eric, let's take a step back. We can take a breath right now. Hopefully folks get an idea of what the conversation is going to be about. So could you tell us a little bit more about your background? What led you into the foray into AIML, AI and machine learning, right? And your role at Gooder AI, right? So tell us a little bit about your early roles and, kind of how you got here.
I was a computer science professor at Columbia University, where I focused on teaching all the AI courses, graduate level machine learning, AI, artificial, advanced intelligence systems, those kind of courses. And that's also where I got my PhD in computational linguistics, or basically the primordial versions of language models in the 90s, in the intersection of that and machine learning. My interest in the area originated well before that, in the late 70s as a kid, when I got interested in the idea of artificial intelligence. The idea of artificial intelligence is cool. I mean, it's fun if you want to philosophize or write science fiction. I love science fiction movies and books and everything. But I'm not sure that the idea has a lot of value for engineering. When you want to build something, you can't engineer something, you can't build unless you have a well-defined goal. But the concept of intelligence and how that should be applied to a machine is subjective, anthropomorphic. So it leaves a lot of problems of what's the goal and what are we trying to do here. But at the same time, that umbrella area of AI certainly includes a lot of very valuable technologies that can be applied in lots of ways, including machine learning, including large language models in particular, which are an extension of machine learning, or a use of machine learning. But in any case, so originally I was like, hey, this is cool. How, you can program a computer to do anything. It's the ultimate general purpose machine, if only you know exactly how to program it. So this whole area of people trying to figure out how to make the machine, quote, intelligent or think like a person and such, really fascinated me. And then in the very early 90s, as I was transitioning to grad school, I kind of decided that the only potential for the machine to kind of scale up the complexity and capability levels is machine learning, is for it to basically learn by itself, learn from example, be guided in that way. And at the same time, I began to eschew the philosophy, like we're never going to be able to think about how we think well enough to replicate it with a machine. So I've become very practical and hard-nosed, and I've also become a bit allergic to the hype, the over-promising, the degree to which the narrative promises that we'll have, AGI, artificial general intelligence, which is essentially artificial humans. And I think that kind of over-promising is catchy and effective from a sales point of view, but it's going to get us all in trouble. And it's definitely gotten a lot worse with the advent of large language models because they're so seemingly human-like. While the technology made a spring forward, the fantastical storytelling sprung forward 10 times as much.
I guess when we were talking right before this, I guess you got into consulting also, and you tell us a little bit about that and Machine Learning Week.
Yeah, I've been an independent consultant for more than 20 years and CEO founder of Gooder AI for 2 years. We founded Machine Learning Week, originally Predictive Analytics World, in 2009, and that was the first conference that was not academic, not R&D, but also vendor neutral on the enterprise machine learning, which for the most part, until 3 years ago, really was those types of predictive use cases.
Cool. And then also you've authored some books, and maybe tell us about some of the books that you've written.
Yeah, I've written 2 books, Predictive Analytics, which is a bestseller. It's been adopted in hundreds of universities. And more just last year, the AI Playbook, which outlines the business practice for running predictive AI projects successfully through to deployment, since most of them have sound number crunching, and the core machine learning method that creates the model is good, but it doesn't get deployed. So there's an organizational problem, and there's an organizational framework and paradigm that the book lays out. Similar, broadly speaking, similar issues apply for generative AI projects, which also are having trouble getting from pilot to production, very much so. Both of these books describe the technology in a way that's meant to be accessible. And I think that that's really, really important, because I believe that the only way we're going to kind of successfully bridge the gap between tech and biz, between data scientists, quants, number crunching, and data professionals, and their counterparts, the business stakeholders, the decision makers, their customers, people in charge of the operations meant to be improved by predictions or machine learning models, is if they kind of can get on the same page, speak the same language, collaborate deeply end to end across phases of the project. And that also necessarily means the business stakeholders need to ramp up on a certain very accessible, cool, interesting, semi-technical understanding, which is more than an hour conversation or presentation. It's basically a book's worth. So that's the intent for both of these books. One of the main goals is for them to ramp up conducively in an entertaining, story-driven, and with concrete, specific use cases and case studies. Tone, right? They're used as textbooks, but they're not written as textbooks.
Oh, that's great. I think that's also part of the crux of this podcast. Is I come from more from the business side. I've been transitioning into AI the past 2 years and getting a lot more semi-technical and technical, right? And part of this is to bridge that gap between the business side and the technical side, and having folks like you that can help us do that, right? So tell us a little bit about, actually, some recent awards, recognitions too, right?
The book that came out last year, AI Playbook, won the Apex Award, one of the categories. Media. I can't remember the name of the category. Yeah.
Okay, wow, that's great. Well, congratulations.
Thank
and
you.
Then tell us a little bit more about Gooder AI. First, talk about your role and your mandate.
So Gooder AI is focused on predictive AI, but it uses generative. And as I mentioned real briefly a few minutes ago, the need for these two areas, predictive and generative, to hybridize, to work together, to marry, is absolutely critical, because they both have crippling weaknesses that are preventing them from realizing their even a fraction of their potential. For the most part, the weaknesses of which I refer are that generative AI is generally not quite reliable enough, at least with the scope or intention and ambition of the project gets a little bit broader. And predictive AI is much harder to use, although it's certainly not impossible, but it requires that ramp up. But they can help one another. They're perfectly fit for helping one another. Our product is for predictive AI projects and provides a view into the potential value of a predictive model. So your data scientist has done the number crunching. It's like they've created a model that can put the odds on which customer is going to cancel or defect, right? Or which applicant for credit is going to default, right? Or which transaction is most likely to be fraudulent, right? So they've done their job, and then they give you the model, and they say, I made the model you asked for, and it's sound. It predicts much better than guessing. It's potentially valuable. Go deploy it. And then the stakeholder is stuck with this difficult decision, because a deployment without any concrete, credible calculation of how much business value it could derive in terms of profit or savings or any kind of business metric. How are they going to green light deployment? That would be a real shot in the dark. Most, if you don't know how well a rocket's going to perform, you're going to scrub the launch. And indeed, most of these deployments get scrubbed. So Gooder AI, our software solution, which is a SaaS solution, calculates the business value. The data scientists are generally only trained and equipped to tell you the technical performance in technical terms like precision, recall, area under the curve, and a bunch of stats that are useful and tell you that it learned something that's better than guessing. But they tell you almost nothing about the potential business value in terms of straightforward KPIs like profit and savings. So there's that translation, but more generally, any model has sort of a whole range of deployment options. Should I use this model to target marketing and only market the top 5% most likely to buy, 10%? Should I audit or block as potentially fraudulent the top 2% of transactions, 2.5%? There's this whole spectrum of deployment options that should be explored vis-a-vis the business value. Bridging that gap requires a new type of software, and that's what we provide. It allows you to actually plan, sell, and greenlight the deployment of a predictive model for these predictive AI use cases. And it uses generative AI to help the business stakeholder understand, because in the interface has a very specialized chatbot, which is built on Anthropic at the moment. It does a great job telling you what do these curves mean in straightforward terms that anybody can understand with a little bit of thought. Because these are the types, it's a number crunching endeavor, and you can't get away from the need to sort of get a sense, how well it's arithmetically going to improve the bottom line profit or what have you, right? So it's not the rocket science, that's the learning from data. Rather, it's how to steer the rocket. So that's one place where you can hybridize, right? You can use generative AI to help stakeholders understand what predictive AI is going to do. And then there's another main ways you hybridize, which is the other way around, where predictive can help generative. So why don't I just sort of rattle that off, and you can let me know which part of it maybe we would best use
let's
our
go
time
for
to
we'll
dig
get into
into.
the technology section on the next part. So, what are your main target segments and use cases? So, is it like financial companies? You're doing churn prediction. You're doing fraud detection. So, what are the main areas you're focusing on?
Oh, that's a great question. No, our solution is just as embarrassingly horizontal as the field of enterprise machine learning in general, right?
Okay.
I mean, which, machine learning, right? The Harvard Business Review calls it the most general purpose technology of the 21st century. And they said that before generative AI. So maybe that only kind of broaden, even makes it more horizontal if that's possible. But yeah, we are not married to any particular niche. And as far as our sort of go-to-market strategy, we have a mature product, but we're a very young startup, and we haven't fully committed to how to go to market. But whatever it ends up being, if we focus on a particular niche like fraud detection, reliability modeling and manufacturing, financial services more generally than fraud, whatever that ends up being will still remain as horizontal, just the same as there's so many solutions to do the machine learning part of a machine learning project, right? The learning from data, the modeling, the model training, whatever you want to call it. There's a lot of solutions that do that. So far, there are none that do what we do, which bridges the gap from model development to model deployment and allows you to plan it. It's like a business console for looking at the potential use of the models, and bridging that gap and getting it actually deployed. We're first. We probably won't be last. We expect there to be competitors. But as far as all of the solutions, including open source and paid, that do the machine learning algorithms, the learning from data part, right? Most of those are also just fully horizontal.
Yeah, no, that's great. So let's get a little bit into technology, right? Normally I get a strategy and vision, but I think especially for your expertise, and I think what everyone wants to know is, let's get into the technology part. So when artificial intelligence started out, I guess the way I define it kind of is like getting machines or computers to think and reason and make decisions like potentially like a human could, right? And so when artificial intelligence kind of started out, you had Jeffrey Hinton and other folks looking at the human brain, looking at mimicking neural networks, right? And then you get into artificial neural networks, you get into machine learning. For those that are not familiar with machine learning, how do you define machine learning for those that, hey, maybe getting into this, trying to understand AI and machine learning, right?
Machine learning is learning from data to predict. That is to say, learning from experience to predict. Data is experience. Data is not a bunch of boring ones and zeros, and encodes the collective experience, outcomes, and behaviors from history. History has spoken. This is how you learn from it. It derives from that, patterns, formulas, depending on which particular method, whether it's a neural network, log linear regression ensemble, or anything else. Whatever it is, it's meant to discover patterns and formulas, and in that way, it's actually learned from something, and learned can in a particular, well-defined way, right? It's different from the way people learn, but it's well defined. It's deriving these things to put odds on the outcome of new, previously unseen cases, like this particular customer who's been using the product in this way, has been around for this long, any demographic and behavior information, and you want to put odds on the chance that they're going to cancel in the next 3 months, whatever the outcome or behavior is. So you have these completely new, novel situations never before seen, and it works in the sense that its performance putting these odds on previously unseen cases pans out, right? In that sense, it's actually learned something that applies in general. It's learned something true about the world. It's derived. It's also called induction to differentiate it from deduction. Deduction would be applying what you've learned. Induction is to learn it in the first place, to derive a generalization from some limited, even if it's a large number of examples, huge training data, it's still finite and still extremely small compared to the number of possible cases that could ever be encompassed. And then when it turns out that it applies well, the performance holds up over previously unseen cases, you can say that it's actually learned something. So that's what machine learning is. Neural networks is just one way of doing it, but a particularly successful way, especially when it comes to creating, well, the whole field of deep learning and getting the things to scale up over large inputs like a full resolution image, and then of course large language models.
Yeah, I think if we apply it to, let's go back to the bank case, right? There's a small bank and they have a couple of employees and they're trying to predict fraud or churn, right? You can go hire some folks and they can go into an Excel spreadsheet and try to look at some of the data in the columns and do some linear regression and try to make some predictions on what's going to happen, right? But then at some point, then you can use more sophisticated models like stats tools and SAS and all these, all the other tools. But when you get to large volumes of data, if you get to a much larger bank, right? There's going to be, I think I was talking to Ari Kaplan from Databricks, and like an airline or even some of these banks, they have thousands or even millions of columns of data, right? And that gets overwhelming for a human or even some of these simple statistical packages, right? So that's where you get to machine learning that can handle all these things. And there's so many different variables in there. Then you get into these different types of packages that you use, whether it's, regression, decision trees, whatever you're going to have, right? That's going to be able to start predicting, making sense of that data, find the patterns, and trying to assess, okay, is this person going to churn or is there a fraud potential? Because an individual, college hire coming out wouldn't be able to process all that information in a meaningful short time frame, right?
Oh, absolutely not. I mean, that's the whole name of the game. And the thing that's most sort of pertinent and salient, like the big deal here, the thing that's big about big data isn't so much how many columns as it is how many rows. That is to say, how many examples from which it's learning. And there can easily be millions and millions of examples. Often there is. There may only be 10,000, and that can be perfectly viable. It just completely depends on the particular project, use case, and industry and such. But even if it's only 10,000, yeah, I mean, people can do anything that computers can do one step at a time. It's just they'll like literally take millions of hours more, millions of times as much time, right? So it's more about the idea that we're doing it algorithmically. It just so happens that electric computers are the best way to execute algorithms. So we have these algorithms that work in the sense that they derive models, they generate models, they learn the models from that historical data, and that way, and the models can be extremely sophisticated. Yes. So in general, the whole field of machine learning is just sort of the ultimate manifestation of the idea of being data driven rather than gut driven.
Right. And then what they're predicting typically has to be in machine learning, where you differentiate from generative, right? It has to be pretty much in the data set, right? They're not creating new information or new data sets in a sense. Can you clarify some of that, machine versus generative?
No. What I can clarify is that you brought up a great philosophical question, because that's subjective. Like, what would make it new? If you have generative make a new, I just had my 5-year-old create his first generative AI image, and I let him do it. I said, "What do you want to do?" And he said he wanted to do a poop on a seesaw, and it worked. So the question is, when you create a new image, is it new? Is it novel? Is it just sort of mimicking styles? Right? That's a subjective question.
Well, that part is true, and we'll get into that part too. But I guess, like in the churn model, right? If the customer or if some data is not within the data set, right, the machine learning model is not going to produce something or make a recommendation outside of that data set, right?
What do you mean by a recommendation outside I mean, in general, the name of the game is to generalize. It's to find patterns that hold in general beyond the limited number of cases from which it learned. So that's the very point of machine learning, however you may be using it.
Right. I guess the way I would see it too is like going back to what you said about decision making, right? So now say that this machine learning model tells bank A, out of your customers, these are the ones that are most likely going to churn, right?
Yeah.
And okay, and depending on if you filter that data set into the highest value or the most likely, whatever, you got to put those things, right? I think where the decision making is like now the executive's like, okay, that's great, but what do I actually do, right? And so I think that's where you get into like some of the generative AI. The hybridization is like, okay, what are the decisions? What are the, do we integrate some sentiment analysis? Do we integrate other pieces of information to augment this so that it allows the VP of customer care or customer retention, and then it creates, hey, these are the top 2 or 3 things you need to do based on sentiment analysis. There's everyone's holding too long, 30 minutes online to have issues, or if you implement some self-care, right, you can reduce churn by X, Y, and Z. I'm just brainstorming right now, right? So what are they going to actually do? So would you have to marry, like in a hybrid model, more of a generative AI model versus just a pure machine learning aspect?
You don't have to make it that complex. I mean, as sort of one of the first thing I led with when your first list of 3, my first answer there was, let's start using predictive AI a lot more. It's got to reach its potential, that even without a hybrid. And the use case, the value proposition, after you've predicted and put the odds on who's most likely to cancel or churn, well, for that particular use case, it's usually targeting a retention offer. So whether it's a salesperson who's going to fly over, wine and dine them and give them a foot massage, which is very expensive.
But does the machine learning model give that recommendation, or who makes that? Who creates that strategy?
Typically not. So the typical churn modeling paradigm is you're going to target retention. It's not usually going to be it's not going to be in-person wining and dining. It's usually going to be a discount meant to retain them. So let's say you get 15%. You're going to give 15% off and say, "Hey, we love you as a customer. If you'll commit to another year, you're going to get this free phone," whatever it is. That discount, that investment, by definition, you can't afford to give it to your entire customer base. Prediction is the only recourse. But if you can give it to the top 20% most likely to defect, now a lot of them actually won't defect. You will have predicted wrong, but you'll do a much better job at giving it where it's needed. And hopefully it'll pan out and it'll actually influence and affect those destined to leave to actually stay. And you can do that. But that story applies in general for all use cases of predictive AI. And that's what we refer to in the case of predictive AI as deployment, operationalization, putting into production, where you're actually systematically acting on those predictions in order to drive a decision of whether to contact, investigate, incarcerate, set up on a date, or medicate, whether to do routine maintenance on a machine most likely to break down, whether to drill for oil here, whether to check out the satellite's batteries more likely than average to run out over the next month, right? Whether to block this credit card charge is potentially fraudulent. So to the degree that the deployment, the use, the acting on the predictive output, to the degree that can be fully automated, and in general, those types of things have more potential to be autonomous than generative. That's the ironic thing. Generative AI is much more seemingly human-like, but much less potentially autonomous. Now, there's plenty of predictive cases that are also not potentially autonomous, but there's plenty that are, because they tend to work in the realm where they don't have to predict perfectly. We don't have a magic crystal ball. We're never going to have high confidence in general about who's going to click buy, lie, or die, but we can predict a lot better than guessing, and that has a great improvement to the bottom line. So, for example, with blocking fraudulent card payment transactions, that can be done instantly, autonomously, automatically, without a human in the loop. Even though it's going to be wrong, it's just going to be wrong a lot less often than allowing all transactions to go through automatically without blocking any of them.
Yeah, and then going back to the 15% discount, that may make sense from some of the lower value customers, right? But say it's your number one customer, right? Or even your most high value customers, you probably want to do, and from a pricing strategy perspective, not offer discounts, because that that's a little bit of value destruction. You may increase churn later. But going back to what you said,
and with fraud, that turns out to pan out for most of these, or a lot of these use cases. So, for example, with fraud, you're taking a risk every time you block a card transaction, a credit card transaction, or ATM, because you're going to annoy a legitimate card holder, right? If you block them, and they may stop using your card or even cancel it, right? Or start using other cards in their wallet instead. So there's a cost to that, to what's called a false positive. But there's also obviously a much bigger cost of false negative, because you allowed fraudulent card transaction to go through, and typically the bank is responsible for the money that the criminal got away with. It actually pays to not only pay attention to the degree of risk, which is the job of the machine learning model, but also the size of the transaction. So putting it into monetary terms, again, very important.
Yeah, and going back to the discount on, say it's your top customer, right? And maybe the discount's not the best strategies. Maybe it's the whining and dining, or figure out what is the problem with it. Maybe it's an account management issue. Maybe it's other features and benefits that maybe another competitor's coming in and providing, right? So I guess in the evolution of AI, and that's what we're talking about, how do we get to that, in terms of addressing some of those things, more the softer and the less deterministic things that are pure math, right?
Well, so the lowest hanging fruit is where it can be autonomous, or at least semi-automatic, and that it can be done in the predictions, that is to say the odds, the probabilities, can be applied in a relatively rote mass way, right? It's hard, cold number crunching, right? Business is a numbers game, and we're tipping the odds a bit in our favor and playing that numbers game more effectively, which turns out to have a dramatic impact on bottom line business metrics. Those are the lowest hanging fruit, right? If you want to take a step up or 5 steps up, and especially in with all the stories about what generative AI is supposed to be able to do, and sort of automate more high level business decisions, not only target the efforts towards customers likely to leave, but also like look at everything about them and makes a customized offer and treatment for each individual. That's suddenly becomes a much, much, much more ambitious project. And that's the problem, is that because language models are so seemingly human-like, and it's very easy to work up an amazing, impressive demo, and they may even be getting the answer within reason or correct most of the time, the fact is they're going to be prone to errors. So you're exposing your whole project to a great potential for failure, just because you escape the feasibility zone so fast when you start increasing the ambition of the intended scope of these projects.
No, that's great. I mean, I think that we're going to dive deeper into some of these topics too, but just take a little step back. So, what about the AI Space podcast resonate with you and made you say, hey, maybe I should be a guest on this show?
Oh, it's a no-brainer. I mean, you guys bring the energy. In fact, I think I've been on like 50 podcasts since my second book came out last year. You're the only podcast host before we went live who said something like "bring the energy," but that was what I was already thinking coming into this, right? You guys sort of are very value oriented. You're really helping make the stuff accessible and delve into it concretely, but you're doing it, in an energized, excited way, right? Nothing droll about it.
That's awesome. Well, I appreciate that. So, before we continue, I want to invite everyone to follow Eric Siegel and Gooder AI. Definitely like, comment, subscribe to the AI Space podcast, because that helps us to grow the show and have more impressive guests like Eric. Where's the best place for folks to follow you, or get in touch with Gooder AI?
Sure. Well, Gooder AI is gooder.ai. My newer book, AI Playbook, is the website's really pretty easy to remember, because remember it's about the playbook paradigm framework for running these predictive AI projects, and we call it BizML, so business practice for running ML projects. So bizml.com.
I'll make sure to put all these. I'll make sure to put all these up too. So
okay, awesome, yeah. So bizml.com goes to the book, and there's other pages on that website about my other book and about myself. So I'm on Twitter. I'm easy to find on LinkedIn.
Cool. Well, I'll make sure to add all those. And if folks out there that are kind of stuck in the space, trying to figure out AI, etc., if you're looking to talk to someone, book a meeting. 15 minutes. We can help you move forward. So let's shift gears a little bit. You've been in this space. You've been professional experience 30 plus years, right? What do you think are some critical insights around vision, mindset, strategy that's critical for long-term success?
I think that maybe I dug my own grave when I was 10, and I decided, hey, this AI concept is so cool. And now for the last 30 years, since I was an adult and actually professionally focused on machine learning, although I would qualify that, I don't know about professionally. I've been professionally focused on for 22 years. Before that, I was an academic. Let's call that I am a recovering academic. No, academia is great for the core algorithms, but tends to miss the boat as far as the business context needed to get these things actually deployed industrial, even more than industry does. And industry fails miserably so far. That's why I wrote this second book, the AI Playbook. Anyway, having dug that grave, now that I'm in the grave, I've made my bed and I have to lie in it. It takes a lot of patience because there's so much storytelling around this highfalutin concept of AI and so much overpromising that it's a hype, and it goes through waves. The newest wave takes the cake, but ultimately, it's just you have to have faith, and I think it's reasonable to have faith that the world cares about value. That even though narrative and storytelling has big impact and can sway the tides and all that kind of stuff, it's going to come back around to what's an actual concrete deployed, productized, or operationalized system that's actually working and is provably valuable and actually helps the organization in some concrete way. If it's always going to, there's going to be this invisible force like the tractor beam bringing you into the Death Star that's going to always bring us back to sort of being more reasonable. That's the antidote to hype, is to focus on concrete, feasible use cases, projects that actually improve the bottom line for the organization, that improve existing operations or introduce new operations that are of particular specific value to the organization. Yeah, I mean, a lot can get lost in the woodwork. People think predictive AI is arcane, but it isn't. It's predicting who's going to click, buy, lie, or die in order to directly inform decisions in well-known established operations, right? So there's some detail to get into that. And as I said, it's more than an hour. It's more like a book's worth, but it's not a technical book's worth. Getting into that, being concrete about the exact use case and value proposition, that's the message that, even to the degree people are sort of glossing over the details in an error-prone way, or falling for the over-promising, overzealous narrative and false promises of the hype, I think a little patience goes a long way, and keeping the things focused back on concrete value.
I totally agree with you. And because, one thing about this podcast, I'm never going to be a market shiller trying to hype stuff out there, right? I'm not going to be like ChatGPT 5.0 or Nana Banana, or, every agents are going to take over the world, that kind of stuff. I'll actually take a step back and say,
did you just make that up, or is that something, Nana Banana?
I think it's the Google, whatever. Didn't they come out with something like Nana Banana, something like that?
I don't know.
Yeah.
I didn't know whether you were just
making the correct name, but I
thought that was made. I couldn't tell. It's like a nonsense word.
Well, I mean, I actually made a nonsense word out of an existing thing to kind of like exaggerate exaggerate the nonsense that's out there, right? Because someone will say ChatGPT 5.0 is going to change the world, and 3 days later, sorry, we were wrong. So we'll never do that. And I think it's also important what you said about what's real, because I want to invite people on here. And you said the antidote for this hype is having real people, real founders, real developers, real researchers, scientists, people that are actually building in the space, to come on and say, okay, hey, we need to use predictive AI, or these are some of the risks. This is what we need to watch out for, and to ground what's reality. Because and we'll get into this a little bit later on maybe your recent article too. I've been a little bit concerned with some of the stock market too, on some of these valuations of what people are doing. But maybe we can jump into that now. That's kind of in the risk. Let's wait till the risk portion of that. How about in terms of, we're talking about vision and strategy, right? So what are some of the actions that we got folks in the audience that are the founders or startups? Okay, they have the vision and strategy. How they translated that into actually execution? What are the actions they need to do to get to their first customers, to grow and scale? What do you see coming out of your role?
Well, you have to eschew the seductive, fantasy, almost irresistible story about AI being a panacea and sort of solving problems for us. One thing that's not going to change, unfortunately, is that problems need to be solved by humans, and we have to architect bespoke solutions to each particular problem, right? If we want to stand on the shoulders of giants and actually make use of these amazing things called large language models that are so potentially valuable in various ways, and have this uncanny, unprecedented ability to work fluently with English and other human languages to a certain degree, the only way to do that is this kind of, if you want to call it, reliability layer. That's what I'm calling it for now. An architecture that ekes out exactly where it's most likely to fail in a way that would preclude its actual deployment entirely. Put humans in the loop to help create those guardrails and to act on them when they fire and automatically hold a case that needs human review before it can proceed, right? The humans in the loop sort of serve on those two levels at the same time. We need that kind of architecture. We need the hard work. AI does amazing stuff, but it doesn't solve problems by itself, at least problems of any kind of noteworthy scope, right? So, and let me be a little more precise about that. If you want to make a chatbot that's able to answer questions about, let's say, 10 or 15 pages of English background information, like an FAQ or something like that, depending on your requirements and on the particular info that we're talking about, but let's say it's some info about the health insurance plan, and that's all it does, is it's going to answer questions, but using whatever different turns of phrase the person happens to use and chains of thoughts and all this kind of stuff. It's very plausible that it will be robust enough with very little customization, and you can deploy it, which is amazing. That I never would have believed that 5 years ago. But you only have to expand the scope and intention of that thing, go from 10 or 15 pages, 10 or 15 documents, or let alone 10,000 documents, or deal with sensitive information that's only supposed to divulge in a restricted way to certain people, or allow it to conduct transactions such as purchases or changes to page reservations. Once you start expanding the scope just a bit in those directions, all of a sudden the thing is going to be making errors that preclude its deployment, right? The system will no longer be viable unless you have some very bespoke layer of reliability management on top of it that's semi-autonomous, keeps the human in the loop, and sort of develops an ever-evolving and growing number of guardrails. So, and that everything I just said really is about generative. Taking a step even further back, just as we need to solve problems as humans, and that's not going away, we also need to have a problem to solve. So where's the lowest hanging fruit? Where's the best opportunity for any of these types of technologies, whether you want to call them AI or not, to improve your organization? It's just going back to basics, right? So there's a lot of pressure to believe the AI hype. It's a very seductive story. There's a lot of extremely wealthy and powerful people who are publicly buying into it and promulgating the hype narrative. But we must continually counter that and pull back to concrete value propositions, and using this technology as well as we can effectively to solve problems which will involve human problem solving at the outset in terms of architecting the overall solution.
Right. No, typically I talk about, how do you grow and scale a business, right? And, going back to the MIT paper that where 95% don't generate ROI, right? Well, because a lot of people are doing it for the news media, the hype or whatever, but I might give you an example. When I started this podcast, I was using some turnkey services, or at least they were supposed to be turnkey, but to get to the next level, right, I had to end up doing a lot of my own creative thumbnail design, titles, keywords, all this stuff, right? And then I started using some AI tools, etc. Then I actually took a lot of stuff in-house, used the AI tools, etc. Started using a different team. I actually cut 60% of my cost, improved my quality, improved my time to market, those types of things, right? Because I was trying to, going back to that 95%, because I was applying it to, okay, what are the things that are going to be, first, how do I use it to help me on my bottlenecks? What are ways to reduce costs? And what are ways to increase value in terms of the output, the creativity, right? And those are things I focused on. And I think that's what a lot of companies don't do, is like, you have to have an end result in mind, but what are the levers that are going to get you that end result, right? And I think that's your thoughts on that.
Well, everything you described, where you're basically using it to create creatives, right? Whether it's graphics or written text, those are intrinsically not autonomous use cases. They are very practical, and it's very effective. You're the human who's always in the loop. You're like, draw a new logo, and then you're like, I don't like that logo, or it doesn't work, or whatever, and it's iterative, right? And I do that too, right? If you go to my Forbes webpage and sort of glance down all my articles, it's painfully obvious that I'm using Gen AI to create the images that goes with each article, because why not, right? I have a particular metaphor that I want to play out that's striking or what have you, and it's just the easiest way and least expensive way to do it. So the hype and overpromising narrative I'm talking about and the reason that AI is so overvalued and overinvested is because of the promise of autonomy.
I mean, it takes to do autonomy, right? Somebody has to actually go build the AI agents, the agentic board or whatever, and they have to have domain expertise. So say you want to go create a sales campaign. Well, you need some sort of a CMO, digital, has that competence to know, currently maybe manual with some systems, right? Okay, I put this into my CRM, it creates a campaign, blah, 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 right? Email, LinkedIn, or whatever. But somebody actually has to know those steps. The AI itself is not going to build that out first. Somebody actually has to go design that out first, and then test it out. And then, as you say, human in the loop, make sure it's all. At some point, then it can go do it by itself. But then you need some sort of if this AI gets smart enough. There's cases where sometimes the AI rewrites the code or whatever. So you got to put the guardrails and have humans in the loop to make sure that things don't go off the rails, right?
Yeah, exactly. To restate something I said early on, I'm pushing hard against the hype because I think it's a really big problem. I think the overpromising is going to lead to a great crash, disillusionment. I don't know if it'll be an economic crash or when it's going to happen or
Do you
whether
think this is kind of reminds me of where kind of like 98, 2000 .com bubble, some of this AI bubble seems a little reminiscent of that. What are your thoughts?
I mean, I think analogy only goes so far, and that it could be worse than that.
Oh, yeah.
Because what happened with internet and also happened with the advent of electricity 100 years before that is that, sort of the value realization, the time before realizing the potential value was underestimated, and it just took longer. So it kind of went through this wave, right? Whereas the thing about the AI hype is it's promising artificial humans, right? Supreme autonomy, which I believe is not realistic. I think that we could have artificial humans or AGI or whatever you want to call it, theoretically, in the very distant future. But I believe that the technology we've developed so far does not represent a concrete step towards AGI. So I think that there's a big problem with that.
Well, I even think what we have now, what we consider foundational models, are not sufficient because all it does is predicting the next word in a sequence is probabilistic, right? And then even there's an Apple paper we talked about we had Babak Hojat from the CTO of AI of Cognizant on the episode, and we talked about once you get beyond 1,000 iterations, right? The models in terms of reasoning kind of break down. 1,000 iterations, like a million permutations or whatever, right? When you get into the more deeper and long term horizon stuff, a lot of these models do break down, right?
Yeah. What do you mean by iteration? Can you give me a
Oh
specific?
yeah. So like once you get to so the one example is like the Tower of Hanoi, where you have the cones, right?
Sure, I know
So
that one.
you have to move them, and then there's recursive, right? So if you have like 1,000 cones, that's that to solve it would take over a million iterations of moves
So
or
it's an
whatever, right?
exponential thing. Yeah.
And so at that point, that's where these models break down, in a sense. It's like once you get to that number of, and so it's not because right now these models seem to be like very good guessers. They're doing pattern recognition. Are they really doing reasoning, right? And that's a question is like.
Well, I mean, that's another one of those sort of philosophical. Depends on what you mean by reasoning. I mean, I think that they really do. They really have effectively captured a capability that relates to the meaning that humans put to words and sentences and paragraphs and pages, but only a limited degree. And it's very hard to quantify. I will say that I think that the difference between what it's capable of and what humans are capable of will become increasingly clear, and that we're still under the spell of how capable it is, which is unprecedented, and how seemingly human-like it is. I think you have to get a little philosophical in a way to try to, it's hard for me to really argue. I mean, people want to believe that because the technology is generally getting better, and since it made this big leap in recent years, therefore it's headed towards general human level capability. But my counter argument would be, look, it learned from a lot of human writing. Human writing is a type of human behavior. So it's learning from observed human behavior. What word came next? What word came next? What word came next? A lot of examples of that, a huge number. And it really did learn a lot. But how much of the human's mind can be reverse engineered from that particular observed behavior? Apparently a lot, but there's going to be a ceiling, like a very limited ceiling compared to what humans can do in general.
Yep. So, in terms of democratization, what do you see as the opportunities and challenges to make it AI more accessible to others from a variety of industries, backgrounds, experiences? How can we bridge this gap?
When it comes to enterprise machine learning projects, right, which have been around for decades, but still have really realized only a fraction of their potential, my motto is that the stakeholders need to ramp up on a bit of accessible semi-technical understanding, and that's the purpose of my books. I don't think they can ramp up completely in an hour, but I think they can ramp up in a book. And that's that's one of the main goals with the books that I wrote, AI Playbook and Predictive Analytics. But I think that's what it means to be democratized. I don't think technology can turn a non-quant or non-data scientist into a data scientist. But I think that a stakeholder, so I'm an amateur musician, right? This is an analogy I just thought of for the first time. And when I want to make a nice recording of some silly song I make, right? So I wrote a song about predictive analytics. It's called Predict This. It's a rap. I used to
Did
sing
you do it
songs from
yourself, or did you on something like Suna?
well, that's the punchline where I'm getting to, right? And I wrote songs when I was teaching at Columbia, and I wrote a song when my mother turned 60 a long time ago, 20 years ago, not that long. And and I wanted to make some of these every once in a while. I'm like, I want to make this a really good recording. I'm an amateur musician, so I would hire a music producer, right? An actual professional for this sort of limited duration. If you're a business stakeholder and you want to do what data science is capable of, you can't just fully democratize it and expect yourself to act as the data scientist unless you go get a degree. But you can ramp up quickly on a semi-technical understanding and play that vital, critical part of the project, because data scientists can't operate alone in a vacuum. It needs deep collaboration between the biz and tech sides. That's the best way to sort of democratize access, but it doesn't avoid having that data scientist human in the loop.
So, in terms of ethical AI, how do we balance AI innovation with responsible development? Maybe talk a little bit more about your Forbes article that just came out, hot off the press.
Let's see. The Forbes article is called "Our Last Hope Before the Bubble Detonates: Taming Large Language Models." That sort of covers some of the main things that I really led with. You asked for that list of three. What are the three main opportunities? And I believe that we need that reliability layer. That's how we're going to realize value. Most of these pilots don't have potential to. It's so close and yet so far, right? It's so potentially exciting, and then you don't actually get it deployed.
So when you say the reliability layer, for those that aren't familiar, what exactly is this reliability layer solving? I mean, they haven't read the article yet. So what
the
is
reliability?
the
It's solving the reliability problem, which is that you can't. If a system's going to make a grave error, let's say 5% of the time, that could very well mean the whole system is not viable. You're not going to get it deployed. So how do you enforce reliability, right? How do you sort of supervise and manage when it's most likely to be about to make a grave misstep? Well, it's a semi-autonomous process. It involves guardrails, and it's got to be architected for each project in a bespoke manner. So that's the solution, but it's project by project. It's not the rocket science part, but it's in depth and it's real human problem solving.
Yeah, sometimes when people tell me, AI agents are going to take over, it's going to happen tomorrow, I was like, really? Would you trust an AI agents to run air traffic control at this point? And most people are like, heck no, right? So if I use that analogy there, right? So the reliability layer in that aspect is, ensuring that you have guardrails in place, you have humans in the loop, and even there's a small percent error, even if it's a 5% chance something can happen, it's going to be catastrophic consequences, right?
Yeah, it doesn't have to be that catastrophic in order for the project still to be not deployable.
And that's just the most like hyperbolic, that's hyperbole right there in terms of an extreme example. Now take that to an enterprise, right? Where you get a false positive and you do something that makes your most valuable customer unhappy and churn, right? That probably wouldn't be a good thing.
Right, if you start driving customers away.
And one other thing you talk about, when we talk about bubble, one thing that's concerned me too is, because I have invested in some AI companies, and I see, AI company A investing in AI company B, investing in AI companies see, like, okay, I just gave you $100 million, and you're going to give them $100 million. They're going to give you $100 million, and it's like a recycled air conditioning, recycled air. And I was looking at this like, it just doesn't make sense. And so I've actually rebalanced some of my.
So that's a big part of, like, we're right in the middle of a big press cycle around the bubble. Everyone's like, this is evidence we're in the bubble. That's evidence that we're in the bubble. From my perspective, it's the evidence. You don't need to look at dissect the economic signals, and you don't have to listen to some of the pundits. Like, let's see, I kick off this article by saying, the CEO of Databricks and chair of OpenAI are both publicly admitting, we're in a bubble. But just look at the claims that the hype is built on, and the claim is that we're rapidly approaching artificial general intelligence. That's a very problematic claim. I would go so far as saying it's a ghost story, right? The machine comes alive. I think that alone means that at one point or another, there will be disillusionment, there will be hell to pay, the executives are going to become wise. But just because we're now getting a whole bunch of press saying we're in a bubble, and this could be really, really bad economically for this, that, and the other reason, even that still doesn't mean that the bubble's about to pop. It still might take 5-7 years. Probably not.
Yeah, no, you're absolutely right. Because I don't care what the press says. Because I don't pay attention to a lot of media. I actually look for my own signals, right? At the end of the day, you got to use common sense, right? Like you said, the hype that's there. I've had enough. I've been doing this now for 10 months, and I've had some amazing guests. And from what they've said, we're not as far as long as everyone's kind of portraying, right? And I just had a recent episode. They're actually exploring living neurons to do AI processing, and it's supposed to be 1 million times more energy efficient than silicon chips and stuff like that. But even we're still a long ways. I'm like, wow, have we officially entered the matrix at this point? Because they're putting living neurons in a fridge, and they're actually able to do some AI processing and control an AI butterfly, etc. Right? But a lot of this stuff is going to take them 10 plus years to. They're raising money, and it's going to take 10 plus years to even get to a stage where it could be potentially viable, right? So I think we're, in a lot of ways, there may be some really cool stuff in the next 2-3 years, but where you said like AGI, all that stuff, I think we're much further away than people say, right?
Yeah, I think, and also, I'd like to remark on that. And I heard a good part of that episode. I thought you conducted a great interview there on the living neurons topic. But I also just want to warn that changing the way a computer works to be biologically based or be based on quantum or anything like that, still, what that basically means is the computer might be faster or run more efficiently in terms of its use of electricity or whatever resource. It doesn't fundamentally change what the computer can be capable of. It doesn't change the fact that computers only do exactly what we program them to do. How are we going to program it to be capable of human capabilities in general? Humans are these very incredible, very particular things that evolved in this very particular environment. Unless we simulate fully that environment, we're not just going to magically replicate them, especially if the only thing we're learning from is what they write. So the idea of creating an artificial human, of a computer that's capable of almost everything a human can do in general, is audacious, and there is no evidence that we're headed in that direction. And the change of how the computer operates under the hood, instead of electricity, neurons, or quantum, doesn't fundamentally change that issue.
Yeah, no, I think those are great points. And my other concern that I bring up on a lot of these podcasts too is, what exactly are these things being trained on too? Not just general data, Wikipedia, Reddit. We talk about a lot of the stuff that's on social media. There's a lot of violence, sexual content, garbage, I would say, right? And are these things really being trained on the best of humanity or the worst of humanity? And then say that AGI does come 10 years from now or whenever it comes down, what are we actually creating or producing? Because based on the data sets that are being provided to it, right, and how it's being trained and what it's seeing, and that's my concern right there.
So is garbage? Is that the French pronunciation?
My version of it, yeah.
Sophisticated garbage.
Yeah.
Yeah, I mean, there's clearly a lot of ethical issues about what language models do, and there'll never be a resolution of. There's no such thing as an unbiased person, and nor could there be an unbiased entity that generates human language. So that's somebody else's bed that they've made, and they have to lie in it.
Yep. Well, we're actually, coming up on time, actually overtime, and I don't mind that. But we've had a great conversation. Concluding thoughts, insights, encouragement to those seeking to get into this space or struggling to build their businesses?
Yeah, I mean, I'm a techno optimist and enthusiast. I think that neural networks, language models, machine learning, these things are amazing. They're extremely interesting. They're extremely potentially valuable. And to the degree that we can stay away from exaggerated stories about what they're capable of and focus on concrete, feasible use cases, there's a lot to be gained and a lot is sort of an endless amount of value that we can realize.
Well, I can talk to you probably all day about the future of the AI space, machine learning, etc. We're coming up on time. Where's the best place for our listeners to learn more about Gooder AI or connect with you?
Yeah, just go to Gooder AI, search my name on LinkedIn, or maybe you can link me to LinkedIn if you want.
All right, fantastic. Everyone make sure to check out and connect with Eric Siegel. Don't forget to follow us on LinkedIn, subscribe to our YouTube channel. Find us on your favorite podcast platforms like Spotify and Apple. Eric, I've learned so much from this episode. I can't thank you enough helping us to ground this space. I think that's very important. Thank you for sharing your insights, but also how you're trying to help people to ramp up, marry the business and technical side to get into the space. I'm your host, Sanjay Kalluvilayil, founder and CEO of Stonehaas Advisors. I hope you gained a wealth of game-changing real-world insights to grow, transform, and scale to new levels and dimensions, leveraging AI. See you all next time. Thanks so much.
Thanks, Sanjay.